Good morning, class, and welcome to this lesson on Kinematics 2, speed versus velocity. Today we will compare and contrast speed and velocity. Okay, so um, this is going to be simple if you understand the difference between distance and displacement. So the difference between distance and displacement is the same as speed and velocity. Okay, so distance is a scalar, speed is a scalar, displacement is a vector, velocity is a vector. Speed is distance over time. For example, something like miles per hour. Okay, miles per hour, distance over time. Displacement, or velocity, is displacement over time. Or we might write x final minus x initial over t final minus t initial, or we might even write this as delta x over delta t. And some people even, and you might even see this where they put little arrows above the x's here. That means it is a vector. Okay, that doesn't mean anything else besides it's telling you it's a vector. So velocity is the change in x over the change in x over the change in t. Okay, so pretty simple. So once again, if we go back to the same example we had earlier um, of the track, and we are running around this track here. This track isn't good. My last one, okay, it's more oval. You know, if we covered 400 meters, if we covered 400 meters in say 400 meters in say 80 seconds, we would have 5 meters per second. That would be our average velocity. That would be our average, our average speed. Okay? And if we did the same thing, our velocity here would be 0 meters per second because our displacement is 0 at that point. If we take the average velocity of this whole track, the displacement at the end is 0. Okay? And so this leads to us having to deal with our first situations of negative numbers in physics. Here's an example of people going down an escalator and up an escalator. Well, what this picture is trying to show you is that these escalators are going at the same speed. They have the same speed, but they have opposite velocities. They have opposite velocity. So let's say this escalator is going up at, I don't know, 1 meter a second that way. This one would be going down at 1 meter per second that way, negative 1 meter per second the other way. So it is possible to have negative velocities. It is possible to have negative velocities. If you look at this picture right here, this jet, this very fast jet car, is driving down, and it covers 1,609 meters in 4.70 seconds. Okay, I believe this is an example of the fastest car in the world. Okay, if it's going the other, if we call this way positive, if we call to the right positive, then that means if it's going the opposite direction, it could have the same exact velocity going in this direction, but it's going to be negative. Okay, so that's about what, 400 meters per second about going in this direction, positive. This way it's negative 400 meters per second because it has a negative velocity. It has opposite the velocity. So we're going to start putting in numbers, and when we plug numbers into an equation, we have to realize we have to make sure we're plugging in the right number, because what's going to happen in a lot of physics problems, it's going to say something like, one ball is traveling to the right and is traveling at 10 meters per second, and the second ball 2, is traveling to the left and it's traveling at 5 meters per second, you have to know. You have to know, based off this information, okay, when I'm plugging these numbers, 10 and 5, into whatever equation I need to plug them into, when I plug them in, if I call to the right positive, then I'm going to plug in 10 meters per second. And if I call to the left negative, I'm going to plug in 5 meters per second. And you might hear me saying this, and this is going to be um, one of the first times you may have heard this before, but when it comes to algebra, when it comes to math, we like our Cartesian coordinates. We like our x and y axes. Okay, we like x going that way and y going up. And we like positive x here and positive y there and negative x here and negative y here. But this is just what we call a convention. Okay, we set up our axis this way to make everything nice. Everybody knows that positive x is to the right and positive y is up. However, if we have a problem in physics and we decide to say, you know what, it works better for me, I'm going to call that way positive x and this way negative x. If we go back to our original problem, all I have to do when I plug it in, I'm going to say, all right, if it's going to the left, it has positive 5 meters per second and negative 10 meters per second. So for you as beginning students, this is your first introduction to realize it doesn't matter what you call positive, and it doesn't matter what you call negative as long as you're consistent. If I decide that everything to the left is positive and everything to the right is negative, then as long as I keep my numbers consistent, the math will work out. And this is where most people run into problems, is because once you change one sign or once you put in one incorrect sign, it can mess up all your numbers. So just keep this in mind. You get to determine what this sign is. You can determine the sign. You just need to be consistent.